All right, so this is what we'll do for homework. So I'll just show that to you here. And again, the extra practice will be your 27 to 29. The APFRQs are kind of some review stuff from earlier. But do notice that on the page 29, there's a number 20, the last one's number 24, and it has parts A and B and C. Do parts A and B, but not the C, because part C asks about independence. And that's actually what we're going to talk about tomorrow. So let's go ahead then. And what I want to do is take a look at your page 21. So that was your Venn diagram problems. So that looked like this, your page 21. So let's kind of just check those real quick, see how you did, and then I want to talk to you about something down there at the bottom of it. Make sure we're good. Okay, so here is your Venn diagram with your answers 70, 40, 20. Okay, questions on that? Here's the number 2. There's your Venn diagram for those parts, and 15, 60, and 15. So here is this one, and I want to talk to you in particular about this question right here. So the reason that I want to talk to you about this one is because I want to talk to you about, I want to clarify how this one says wheat and maize, but not rice. And I want to compare that to if it had said wheat or maize. Because what happens is we see we see wheat and maize, but not rice, but we don't think about it being like being so picky and paying attention to it being different, between it being and or. And it is that. Yes, ma'am. Okay, I will in just a minute, but let me get through this one. So when we say how many countries let's do the wheat and maize. What does that mean, and? It's both. So it's the intersection of it. That's the key. So that means this whole little football shaped area right here. So this is the wheat and maize is all this here, but not rice would then take away this piece there. And so your answer is this little part that's 6. Okay, so that's how it is wheat and maize. But let's take a look. What would it have looked like if we had said we had done this one here, wheat or maize? What would have been that section shaded in that case? All, or is this or that or all? So or would have shaded all of the wheat or maize or both. I mean, of any sort of wheat or maize, that's what you're part of. So if I had said wheat or maize but not rice, then we would have had this and then take away, any of these little rice pieces. So that would have been wheat or maize but not rice. Okay? All right, now on this last one, E, how many countries raised rice but not wheat? So rice but not wheat. So let's see. Here's all your rice. And then I need to not have the wheat. So I'm going to just not have that part there. So what's remaining then is this 5 and this 2. So that's why it is 7. Okay? All right. Very good. So let's move on then to the next assignment you did, which started at page 24. And so we'll kind of just double check some of these with you, and then we'll talk about a few of them. So here we go. Page 24, here was your Venn diagram you should have drawn if you did that technique. That was point 68 is a pool or garage, because remember, or means this or that or both, or is all of it. And then that's point 32, and point 04 is this little piece here. All right, here's the next Venn diagram. You can check that there. Got your point 14, point 04, point 05, so on. 0.77. Go into neither. All right. Last one. Here's your Venn diagram, and then you can answer those questions. So this was actually quite similar to the Venn diagram practice page. So just kind of a little different format. All right, any questions on those ones? Mm-hmm. All right, so here. Okay, so I want to make sure that you are showing the work. I want that statistics notation for sure. Anytime you have the given that, let's make sure we write out that statistics notation because that's your work. And then you can give the answer in decimal fraction or percent. So show this, anytime it's a given that, show that statistics notation. Here, show the statistics notation with your answer. Okay, I want to make sure, look at what you put for C. A common mistake that people do on part C is they put 4 on top, and it is not 4. Okay? Because people put all the aces over all the reds, and that's wrong. So this says, given that it's red, so you need to think in terms of, I have the red cards in my hand, and I have trashed all the black ones. There are no black cards in my hand. It's all red. So of what's in my hand, what's an ace? And there's only 2 red aces in my hand. Okay. So I'm pointing this out to you because that's a common mistake, and I'm trying to, heed you against that problem. Okay. Yes, ma'am. Mm-hmm. Okay. Okay. I do know that like on 2 pages from now, it's pretty tricky, and we're going to talk about that. Maybe we'll go over that. That one I think is more tricky, and so we'll talk about that one on that page. Okay. So let's go to this one. So this is interesting. On this problem here, look at this way that I had organized it, which isn't very well done. I don't know why. I have done this problem for 10 years, and I hadn't thought about a different way to organize it. So here's my question to you. How many of you organized this problem in a table? Did any of you just do that? Well, that's impressive because I've done this for 10 years, and not until third period today did I go, hey, you know what? I could do that as a table. And then I did. So here's what that would have looked like, and it would have made things really easy. And oh my God, 10 years I've done this thing. So anyway, here we go. Take a look. It said there are 24 dogs because see, we have 2 categorical variables. So anytime you have 2 categories, you could set up a table. Male, females category, dog, cats category. 2 categorical variables. Okay. So we were told that there were 24 dogs and that there are 18 cats. And of those, 8 of the dogs are male and 6 of the cats are male. Okay, so then I could do my totals from there. So I knew I had then 14 males total. And so then I can use these totals down here to figure out, what's missing in the female department. Okay, here, then there was 6 female cats and so on. So from all of that, I could fill in the information. This made it very, very easy then to answer the questions here. Because then you can say, like A, out of all the cats, well, that's a total of 18 cats, 6 were the female cats. Okay, and then out of all the females, there were 28 females total, 12 were the female cats. And then out of the 24 dogs, there were 16 of them that were female. And so then we got how that came about. All right. Questions on that? So table 2 categorical variables. Do a table. That makes it easy. Okay, moving on. Okay, this is the page where I think the wording gets really tricky. And the nice thing is that today in class, we're going to have a solid 30 minutes to work on a lot of that stuff. And it's got some tricky wording to it. So, in fact, we'll kind of talk about that a little bit later. So here we go. Let's take a look. So I think the first problem is students didn't know quite how to read this table. Yeah, so that caused the first problem. So let's kind of review that. So here's the blood pressure people. So this is the blood pressure people. So these people, 27% of the sample. So you know what? I'm just going to pretend when I'm talking about stuff, let's just pretend that it's a sample of 100 men. Okay? But anyway, of those 100 men, 27 of them have high blood pressure and 73 of them are okay on the blood pressure. Okay? And so then you go the other way. So here now is the cholesterol. The high cholesterol is this. So you can see that 32% of the men have high cholesterol and 68% of the men are okay on the cholesterol. Okay, so that's kind of the first hurdle, is making sure you could read that. And so now, what's the probability the man has both? So high cholesterol, high blood pressure. That was this section here. Both of them are high, so that's that. And probability he has high blood pressure, so that's this high blood pressure. That is this right here. Okay. Now here is where it gets, very tricky and subtle in the wording. So let's take a look. Okay, so I think one of the keys is, there's a couple questions you could ask yourself. Are you told a fact or a trait that is definitely happening to the person you're sampling? So in this first question here, it says, problem C, what is the probability that a man with high blood pressure has high cholesterol? So I know a fact about the person I'm sampling. I have picked a person, and that person has what? High blood pressure. So that is the given part. And so another way that I've noticed, and things can be worded in so many different ways. So this isn't like a fail-proof method, but do you know that paying attention to where the verb is can sometimes help you? So for example, when I have this verb right here, this depending on how the verb goes, here it's separating my denominator from my numerator. So my man with high blood pressure is my denominator, and then the intersection, also having high cholesterol, is the numerator. So that verb helps you. Now, so here is our given that. So given that he has high blood pressure, so put all the high blood pressure. So I want you to think of it like this. Put all those high blood pressure people in this room. That's this 27 high blood pressure people. So 27 high blood pressure people are here. Everybody else is outside. And it says, of the 27 in here, who of those also have high cholesterol? So if you wrote 0.21 here, that's wrong. 0.21 is, or 0.32. Maybe you put 0.32, which you probably wouldn't have put 0.32 because that's bigger than it. So you might have not done that. But if this had been a smaller number, you might have, I read this earlier and I thought 0.21 was the total of the high cholesterol. But anyway, so it has to be the people in this room, the 27 who have high blood pressure, those who have high cholesterol. Okay. All right, let's look at the next one. This one says, what's the probability that a man has high blood pressure if it is known that he has high cholesterol? So his trait is what? So this guy is a high cholesterol person. So that's denominator. That's the pool of people I am picking from. So the 32% who have high cholesterol. And look here, do not put all of the high blood pressure people, don't put 0.27 on top. I have the high cholesterol people in here. I set the others out away. So 32% have high cholesterol, and so now these 11% also have high blood pressure. Not 27. Where's these other people? They're in the hall. Yeah. Good. Okay, moving on. So this was one where you had two things that had to happen. You had to have a faulty system and have to pay more than $100 for it. So that was your 0.20% chance of having faultiness, and then 40% of those have to pay higher than $100. So that was your 8%. Okay, and then here we've got this is our junior biology majors, and we've got of the junior biology majors who have taken statistics, so that's your denominator, have also taken a computer course. So our denominator is all the statistics students of 52%. And see, look here, all 52%. You could, if you drew a Venn diagram, you can see it very easily. And what proportion of this 52% have also taken the computer course? That's the intersection. So that's that 0.07 intersection is that portion, that intersection. Okay? How come these courses are these two courses disjoint? Why not? Yeah, because 7% can take them at the same time. So do you remember the disjoint definition? Actually, last year I had made a song to it, but I never got it recorded or did the music track to it or a video. So you get a live version of it. So here we go. So it goes to, this is going to be the best day of my life. So here we go. We know disjoint events, they can't happen at the same time. Okay, so here we go. So there are things down on the ground, and there are things up in the clouds. And the things up in the sky can't touch the ground at the same time. They'll never intersect, no. Oh, they'll never intersect, no. Oh, exclusive mutually. Okay, now I'm just put that in there actually for a reason, because this is another vocabulary word, mutually exclusive events. Mutually exclusive events are completely separated and disjoint. Okay, so that's a synonym. So that also means disjoint. Okay. Oh, disjoint can't happen at the same time. Oh, disjoint can't happen at the same time. All right. So there you go. Okie dokie. That's it. Going over all those things. I hope that kind of helped you. And so now I'm going to have you practice all of this stuff. I kind of would prefer if you guys would actually start on this extra practice, pages 27 to 29, and do work. I know it's the end of the day and you're like brain dead, but I mean, we've got 30 minutes here, guys. So because throughout the course of this lesson, I'm going to come back and talk to you about a few little things. Okay, so let y'all get started on that, and I'll come back and talk to you about a few little things as we get going through it. Okay, so we're going to talk about something real quick. Will you go to the bottom of your page 27 and let's look at this problem C, because one of the things that I like about this class is it really makes you have to look at the wording very in a detailed fashion. You cannot just skim these. You have to really analyze all the wording. So what I circled here is what's written. It says, what's the probability that the person is firstborn and human ecology student? But I added some phrasing, or I added something because it sounds very similar. So this is an addition that I typed in here. What is the probability that a firstborn person is a human ecology student? So those are both very similar. And so we're going to do something here. I'm going to give you a minute to look at it and think about it. And odds are going to tell the evens or vice versa. We'll see in a minute about what is the difference between these two statements mathematically. Okay. And so, like, what is happening with those? So let me give you a few seconds to think about that. And then the odds will tell the evens. Okay. So yep. Good job.
Do we always have to write like probability of X?
I want you to do that, writing out the phrase if it's a given that.
Okay.
The other times you don't have to. It's good to, but you don't have to. All right, so the odds told the evens. So the evens tell me. I will tell you that, you know, paying attention to where that verb is can help you if you were struggling with that. Okay, so let's see what we got. Odds told the evens, so the evens tell me who, let's see, who back there, Matthew, is even. Okay, what you got, Eva? Okay, for the second one here. Okay. And what made you decide that your denominator was 113? Good, because out the group we are pulling from is the firstborn persons, okay? And as opposed to the statement above it, which says what? So that's out of everybody. Very good. See what's in front of the verb? This group we are pulling from is all people, all persons in this sample, as opposed to the firstborn person. So in this one here, it was 15 out of 223. Okay, good. So very, very subtle wording, but the denominator, what you're pulling from, was different. Okay? Now, I want to mention one other thing. I know you're not there yet, but let me just go ahead and tell you this, and then we can get started, or I can just let you work. Go over to number 19. Go over to your problem 19. This one's kind of got some review components to it, plus something a little new. So this is 12 batteries. 5 are totally dead, and you start picking the batteries one at a time and testing them. Okay, so I want you to think about for a second choosing 2. What's the probability you're going to choose 2 that are both good? So let me give you a moment to think about that. So is there a question you're wondering to before you can do your numbers? So what's the probability of it being good? How many were good? 7 out of the 12. Okay. So you start picking the batteries though, one at a time and testing them. So once I test one, what's going to happen? I'm going to put it away because it's tested. I'm done with that one. So it goes to the different pile. Therefore, what's the probability that the next one is good? 6 out of 11. Yep, not even 6 out of 12. That was a tendency. Okay. So read B and see what pull from the depths of your before Thanksgiving mind a concept that you see there and how we would attack it. All right, so what's our key thing? At least one. Probability of at least one is what? 1 minus the probability of none. So I like to write more than just none, but I go 1 minus the probability that none of the three what? None of the three work. I just want 1 minus probability that none of this. None of that. Ain't got none of that. Okay, so how does that look? 1 minus, and I need this one to not work, and this one to not work, and this one to not work. So think about that for a minute. One minus the probability that none of the three work. If none of the three work, that means that they're all bad. You thought what? No, at least one of them works. So, okay, and so what we did before Thanksgiving is we talked about like all of these different ways you can have combinations of three, and I want every single thing except for that one time when none of these three work. So in order to get all of these times when at least one of them, here's all the different ways at least one of them works. That's all of the combinations except for this one case when none of them work. So this is 100% of trials. So I want to take 100%, that's one, minus all of these times here, or, oh, sorry, my bad, minus this, and that gives me what's left, all of the times that at least one of them works. Okay? All right, so how did we do this? Bad one was 5 out of 12, and then there we go, and so on. Okay, so I just kind of wanted to pull, that was new, we hadn't really talked about not replacing it, okay, and pulling back from some things before Thanksgiving. All right, that's it. Keep working. You have a solid 10 minutes left, so keep going, go back and do some more problems.